welcome back, guys. This is our last lesson in this unit, and we're going to look at word problems today. So just a little warm up here, and I do recommend you pausing this one and just seeing if you could figure it out. I'll try and explain it though. It's a lot going on here. So let's say 30 children signed up for sports teams. This is a word problem, so please be aware that word problem authors really like to throw you off. That is a word, but they could have written it like this. So be aware of words that are numbers as well. So 30 children signed up for sports teams. This table shows the sport and the number of players needed per team. So baseball, you need 9 players on a team. Basketball, you need 5 players on a team. Soccer, I know it's saying 6 for this league, I guess. And Ultimate needs 8 players per team. Well, the children are supposed to play one sport at a time. So all 30 are trying to play one of the sports. So let's say baseball will be in, March or whatever. So they're all 30 are trying to be on the baseball team. Well, which sports can the coaches choose given the number of students, the number of 30 students? Which ones would be impossible if they wanted every child to play? Solve this problem any way you wish. Pause it or we'll move on here. All right, let's say there's a tennis match. In tennis, you can play something called doubles or singles, and 4 players are needed for a doubles game, and 2 players are needed for a singles. So single means it's 1 against 1, so that would be 2 players. Doubles is 2 against 2, so that'd be 4 players. So hopefully that makes sense. Well, let's say there was 22 players, but 7 games were being played. So how many of these games were doubles games, and how many were singles games? So we could do something called guessing and checking here. So I could say, let's pretend that these two, I don't know, we'll see, doubles game here. 2 on 2, that's 4 out of my 22. Maybe there was another doubles game going on. So we're up to 8 players. So that means 22 minus 8 is 14. Let's have a singles game going on here. So we're up to 10. Let's do another singles. That's 12. 14. 16. And let's do another singles. 18. Let's see. I got 4 on the first court, 4 on the second, so I'm 8. These two are 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm 4 short. So I need 22. So obviously there's going to be some more doubles games going on. So maybe this game become a doubles game. So I just added 2 more. That's 20. That means that I'm too short. Maybe there's another doubles game going on. So let's just be sure. 1, 2, so maybe we can count how many games are actually being doubles. So 1, 2, 3, 4 games are doubles right now, and 4 times 4 is 16. And I'm saying 4 times 4 because 4 games times 4 players on the court. 16, and then there's 1, 2, 3 games of singles, 2 per game. 3 times 2 is 6, so plus 6, that is indeed 22. So what we did here is we, guessed, used some models, and figured it out. Okay, we're gonna same problem here, but let's do it with numbers instead, because it's not always practical to try it with drawing, because it could take a while. So we're gonna use the guess and check method. So let's pretend maybe 2 were doubles and maybe 5 are singles. Let's see if that pans out. I'm just randomly guessing. Let's say 2 games are doubles, 5 games are singles. So the 2 doubles games, that's 2 times 4, right? There's 4 players on the court at the same time. That would be 8 players. And I have 5 games going on of singles. There's 2 players per, so that's 10. Well, I got to add these 2 together. 10 plus 8 is 18. I'm short, so maybe I could readjust my guesses. So what I did was I guessed, I checked my answer. I'm going to try again. Let's say 4 games of 4 players. That'd be 16. So 4 doubles games going on. Let's try 3 games of singles. So 2 players on the court for singles, 4 players on the court for doubles. That'd be 6. What do you know it? 22. So the answer to this problem is there were 4 doubles games or matches, I think I said before, and 3 singles games. The end. All right, I get you to try one. Let's say there's a field hockey tournament. And I know this is not true, but there's really, I think you're allowed 16 players on a team for field hockey. But let's pretend there's 8 players allowed on a team. Well, what if there's 8 teams in the tournament? So there's 8 players on a team, and there's 8 teams in the tournament. How many field hockey sticks will there be? I'm gonna get you to pause there for a sec and press play when you're ready. All right, so before I get started here, what is this unit all about? This unit we've been looking at multiplication and division strategies. So using that information, do you think we'll be using multiplication in this question or division in this question? Well, some clues here. I don't really have any very large numbers, and usually very large numbers are involved with division, larger numbers, but it's not always true. But I have 8 teams, and there's 8 players per team. We're going to be multiplying here, okay? So 8 teams times the 8 players on each team equals, well, we need to know our facts. 8 times 8 is 64. So the answer here is there is 64 sticks in the tournament, I guess. Or between all the players, there'll be 64 sticks. So, I mean, that doesn't seem like a whole lot of steps there, but the trick here is identifying what operation, and operations are adding, subtracting, multiplying, and dividing, what operation is needed to solve the problem. And in this problem, we used multiplication to solve the problem. I need you to try another one. There's 55 students hoping to be on a basketball team. How many teams would there have to be for everyone to be on a team? And the other piece of information that I forgot to write here is there can be 5 players per team. So there's 55 students hoping to be on a basketball team. How many teams would there have to be for everyone to be on a team with 5 players per team? I'll get you to pause that. Try it when you're ready. All right, so like I said before, we're identifying, is this a multiplication question or a division question? Well, if it was multiplication, I would be multiplying these two numbers, probably 55 times 5. Would that operation help us learn how many teams there have to be? Because if we do this, it's going to be far greater than the number of students. We can't have more teams than students, so there's no way that multiplication could possibly work here. We're going to be looking at division. So 55 divided by 5, the 5 coming from the 5 players, is what we're looking for. Now, we've related multiplication division before in a previous lesson, so remember this is the dividend, which is also the product of a multiplication question, and the divisor here is one of our factors, so 5 times something is 55. You need to know your facts here. 5 times, well, you can count your fingers by 5s, but if you know, 5 times 11 is 55, so there can be 11 teams. All right, let's do one more. A coach has between 30 to 40 ribbons for a track meet. She has an equal number of ribbons for each of the 7 events. How many ribbons might there be with 5 left over? So in other words, I've given you kind of a riddle. The number we're looking for is between 30 and 40. There's an equal number of ribbons for 7 events, so it has to go evenly with 7, but there'll be 5 left over. So I want you to think about that. Come back when you're ready. Now, for this one, we're going to have to use that guess and check method. So our answer is going to, the number of ribbons is between 30 and 40. And we're going to have to use this 7 for our information. So we're going to find the multiples of 7 and see which ones go between 30 and 40. Well, 7 times 1 is 7. That's not between 30 and 40. 7 times 2 is 14. Nope. 7 times 3, 21. We're getting closer. 7 times 4 is 28. That's not between 30 and 40, but it's very close. 7 times 5 is 35. Well, that's between 30 and 40. Let's do one more just to be sure. 7 times 6 is 42. That is outside. So this is going to help us. Okay, so 7 ribbons. Well, an equal number of ribbons is 5 ribbons for the event. So 35 ribbons is the number that I am hinting at here. So the answer is there'll be 5 ribbons for each event, and 40 minus 35 is 5 left over. So our answer here is there is 5 ribbons for each event. Well, my friends, that's the end of our unit, multiplication and division. Hopefully you learned a little bit about strategies to deal with such operations, and I look forward to seeing you in the next unit. Take care, guys, and remember, in life, math happens.